All right, we're still in the endocrine system and we're moving on to the thyroid and parathyroid glands. And that's all we're going to cover in this section. So let's go ahead and let's look at these endocrine organs. So we have the trachea here, right? And then surrounding, we have the thyroid. And then if you were to look on the back of the thyroid, so this is the anterior, this would be the posterior view, you would find these little four little kind of round things here, and these are going to be your parathyroid glands. And then if we're going to look at the rat, it's up here. This is the thyroid right here. Basically, what he's trying to say in his slide is that if he points up there in that region on the exam, then that's pretty much all that could be is the thyroid. So I know it's difficult to see, but just know that if he's pointing up here, he's pointing to the thyroid. And then we have this histology here. And on this side, we have the thyroid, and we can see the follicular cells, and then they would be filled with colloid. And then on the other side, we have the parathyroid gland. Moving on, we're going to talk about the hormones these glands release. So the thyroid gland is going to release thyroid hormone. And this is going to be produced by the follicles, so the follicular cells in the colloid. And iodine is an essential element for this process. Now, thyroid hormone targets essentially every cell in the body. And what it does is it increases basal metabolic rate, heart rate, respiratory rate. In children, it's really important because it stimulates growth. It's actually synergistic with growth hormone. And there are a number of disorders that result from either an over or underproduction of thyroid hormone. So first we can talk about an iodine deficiency can cause a goiter, which is an enlarged thyroid gland. Graves' disease is an autoimmune disease resulting from an enlarged thyroid gland. And then we also have hypo hyperthyroidism, and this can result from a number of disorders. So hypothyroidism would be that you're not producing enough thyroid hormone, and things like it's important for metabolic rate and other things. But a person with hyperthyroidism may be sluggish, they may be cold intolerant. Then we have hyperthyroidism, and this is going to be an overproduction of thyroid hormone. Now, there's also another hormone that's produced by the thyroid gland, and this is calcitonin. And this is going to be produced by the parafollicular cells. And this calcitonin, its job is to decrease blood calcium levels. And it typically does this by inhibiting osteoclast activity in the bone. And if you remember from ANP1, those osteoclasts are the cells that are found in the bone that break bone down and kind of like liberate the calcium and the other stuff that is found in bone. More specifically calcium, because that's what we're talking about right now. So what calcitonin does is it stops the osteoclast from breaking down the bone, which means that not as much calcium is going to end up in the blood. It also inhibits calcium reabsorption in the kidney tubules, which is going to make an individual just urinate out more calcium. And the result of calcitonin or its effects are to increase bone density. The calcitonin is an antagonist to parathyroid hormone. An antagonist means that it opposes, it has an opposite action. So parathyroid hormone is going to do, again, the opposite of calcitonin. But they work together to continuously remodel bone. Then we have parathyroid glands, which is going to secrete parathyroid hormone. Remember, parathyroid glands are the glands that you see on the posterior surface of the thyroid. And what parathyroid hormone is going to do is increase calcium levels in the blood, and it's going to indirectly target and stimulate osteoclast activity. So again, osteoclasts are breaking down bone, which means it's liberating calcium. So if it is indirectly targeting and stimulating osteoclasts, that means that more bone is going to get broken down, more calcium is going to end up in the blood. It also increases vitamin D synthesis by the kidneys. I think this is the last slide. Yes, last slide. So that's all I have for the thyroid and parathyroid gland.